So we've been working with right triangles, and we just finished up looking at special right triangles. So if I have a right triangle here, and this is a 30, 60, 90 right triangle, then we can find all the sides based off of just knowing one length. So for example, if we know that this length here is 5, without doing any calculations, we know that the hypotenuse is double that, so that's 10, and this other side here is 5 times the square root of 3. That's just, basic memorization. But what if this angle were 31 degrees? What if it were 40 degrees? We would not be able to find out the other two sides based off of just one side. So what we need to do, what we need to look at in order to figure that out, is trigonometry. Trigonometry is basically the relationship between the angles in red and the sides in blue. And to start off, we always need, well, these are only for right triangles in this video, but we always need a reference angle, and that's what we call theta. Theta is a Greek letter, and this is our reference angle. So there are going to be 3 sides here. Of course, we know that the hypotenuse, we know that there is 2 sides that aren't the hypotenuse. So if this is the reference angle, notice how the side over here we call the opposite side because it's opposite of the reference angle. It's not touching the angle. As opposed to this side, which we call the adjacent side because it's touching it. So there are 3 basic trig functions that we will be looking at, and they are sine, cosine, and tangent. When we write them, we first write the function and then the variable of the angle. So we could have sine of x, sine of y. And notice I'm saying sine, not sin. Don't say sin. Don't be that person. It's sine. So it's sine of theta. We also have the cosine of theta, and we have the tangent of theta. Sine of theta is the opposite side over the hypotenuse. I should clean up that O so it doesn't look like a theta. It's the opposite side over theta. Cosine is the adjacent side over hypotenuse. And then the tangent is the opposite side over the adjacent side. It's just this beautiful little fraction, little function that helps us find out one side if we know an angle and another side, or help us find an angle if we know 2 sides. So what we actually notice is that there's a memorization piece which is called SOH-CAH-TOA. Basically, it's just a nice, cute little way to remember these definitions and these functions. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. SOH-CAH-TOA. A nice little way to remember these as opposed to just straight memorization. So here we have a problem. We have this reference angle theta. We don't know what it is. We don't need to. Here we have a right triangle. And let's say that this is a 3, 4, 5 right triangle. Well, the sine of theta, if I want to find, let's find these 3 trigonometric functions. And I say, all right, well, here's some angle theta. You don't know what it is. What's the sine of it? Well, you know sine is opposite over hypotenuse, so it's 3/5. That's it. That's your answer. Cosine is adjacent over hypotenuse, so that's 4/5. Done. And the tangent, that's opposite over adjacent. That's it. Now obviously, of course, we will be getting more complex with this, but that's a nice little basic approach to trigonometry, right angle trig, and SOH-CAH-TOA.